Hello, welcome to MAT136 Calculus 1B Final Exam Review Session. MAT136 is the continuation of MAT135 with focus on integration techniques and series. Today we're going to cover all the important concepts on the exam and demonstrate them with the past exam questions from 2016 to 2014. First, let's take a look at this list of exam question breakdown by topic. As you can see, the highlights of these exams are the fundamental theorem of calculus, integral properties, substitution rule, and other integration techniques, with focus on trigonometric integrals and substitutions, and a whole bunch of tests for convergence of series. There are two branches of calculus. The first branch is called differential calculus, which we learned in MAT135, and now we're learning the part that's called integral calculus. And now we're looking at a theorem called the fundamental theorem of calculus. It's called the fundamental theorem of calculus because it's so important that it serves as the linking bridge between these two branches. Okay, so there are two parts of this theorem. Let's take a look at the part one. Part one is saying that, say, if I have g of x, it's equal to from a to x of f of t dt. Say, g is an antiderivative of f of x. We use the letter t here because t is a dummy variable. The real independent variable here is the x guy over here. So don't confuse yourself. So if we want to find the differential based on the integral, we'll just say that's g prime of x equal to the dx of a to x of f of t dt. That's gonna be equal to just f of x. Okay, this, I'm sure all of you guys know this, but the exam is not gonna be this easy, so it's gonna do some variation. What if the x here is a composite function? So let's say g of x now equals from a to h of x of f of t dt. So the conclusion will no longer be the same because the independent variable here is a composite function, so we cannot just say it equals to f of x. So g prime of x is actually equal to f of h of x because it's a composite function, but we're not done yet. According to the chain rule, we need to say that there's a part called h prime of x. So now this conclusion is very important, and there's a high chance it's gonna be on the exam. So let's take a look of a question from 2014, part B, question 3. So what it's asking is saying that g of x equal to from 200 to 2x of t to the power of 4 minus 14 to the power of 200 dt. So it's asking for what g prime of 1 equals to. Okay, so don't freak out when you see the power of 200 because it's asking for g prime, so we can just plug in the formula from fundamental theorem of calculus. So g prime of x, here we ask ourselves, should we use the first formula here or the second formula here? Let's take a look. So the independent variable here is 2x. 2x is a composite function, not just x, so we need to use the second one. That means g prime of x is equal to f of h of x. So what is the f here? F here is the t to the power 4 minus 14 to the power 200, so we're gonna stuff in 2x to the power 4 to substitute for t minus 14 to the power of 200. Are we done yet? No, because we need the h prime of x, which is the dx of 2x, which is equal to 2. That's all you guys know. So it actually becomes 2 times 2x to the power 4 minus 14 to the power 200. So now, easy stuff, which is going to plug in 1. That becomes 2 times 2 to the power 4, which is 16 minus 14 to 200. That's 2 times 2 to the power 200, which is 2 to the power of 201. So the takeaway here is that the part 1 of fundamental theorem of calculus, the independent variable could be a composite function or a just x. So you have to be careful, and if it's the second case, you need to plug in h of x, and don't forget about h prime of x right here. Let's take a look at the second part of fundamental theorem of calculus. The second part is saying that if capital F of x is an antiderivative of, say, small f of x, then the integral from a to b of small f of x dx is equal to capital f of b minus capital F of a. And if you change it a little bit, it's also called the net change theorem. Okay, so how can we use this in a test? So it will ask you something like the one from 2016, part B, question 1. So it's going to be an easy one. So saying that f prime of x equals to 16 to the power 16 times x to the power 3 minus 5. And we know that f of 1 equals to 3. So it's asking then, what is f of negative 1 equal to 2? So the main challenge of second part of fundamental theorem of calculus is how you construct the question. So we need to take a look at the original form. So the big F in this one is actually the small f here, and the small f in this one is actually f prime here. So if we say from negative 1 to 1 of f prime of x, which is 16 x power 3 minus 5 dx is equal to f of 1 minus f of negative 1. And f of negative 1 is what we want to find, so we're gonna take it to on a separate side. So we say that, okay, what? F of negative 1 equals to f of 1 minus from negative 1 to 1 of 16x cubed minus 5 dx. That's equal to 3 minus, so it's gonna be 16 times x power 4 over 4 minus 5x, right, from negative 1 to 1. So that's going to be equal to 4x power 4 minus 5x, negative 1 to 1. So let's evaluate this stuff. So at 1, it's equal to 4 minus 5, which is negative 1, minus the value at negative 1, which is 4 minus 5x, which is minus 5. And this is actually 4 plus 5, which is 9. So it's equal to 3 minus negative 9 minus 4 plus 5, negative 1 minus 9, which is 3 minus negative 10 which is 13.